Okay, this is a video tutorial on the use of the Time Sert kit number. See if we can focus in there. 1812 E-Core. M8 by 1.25. The shanks and shafts on this are 5 inches long. Let me open this up here, if I can do this one-handed. And so, inside this kit here, you can see what comes with it. It's more than your normal kit. The normal kits just come with the actual the drill, the boring piece, the insert driver, and the counterbore portion. But this actually comes with, you can see, the drill bit, a measuring tool, comes with the tap, and it comes with the insertion tool. Obviously some inserts back there, a Sharpie, a measuring stick, and also a tap guide. Reason for that being is that this is one of those kits where it's used for more of an odd application. So let me show you what we're going to be using it on here. This application here is going to be for an Arctic Cat ATV crankcase. What I have is I have a M8 by 1.25 threaded hole that's down inside of a counterbore here. As you can see, it's down about 3 inches down, and it is stripped out. Somebody has been into this motor before I got into it. We're doing a transmission rebuild, and that thread was stripped out partially, if not all the way, before I went to tighten up the cases when we finished reassembling it, and then we found it stripped out. So what I want to do is kind of take a look at what the inside of this looks like here, and then we'll do a demonstration of the tool itself. So we're going to get the bore scope out, and we're going to go ahead and take a look down inside. And this is a view inside of the actual cavity. You can see there's not much threads left. You can see the pieces down the bottom of the hole, and they are, you can kind of get an idea here as I pull this thing out how far down those threads are. So the difference in this Time Sert kit versus the standard Time Sert kits is, in essence, the standard Time Serts are using a flange type of insert on them, whereas this one, because you don't have room via the counterbore to put that flange in, they are actually using a double step on the drill, which, let me show you the drill here. The drill has a step on it, and the step actually, which you can see right here, so the drill actually has a step on it, and what that step does, that step creates kind of a, you call it a chamfer, so to speak, that allows the inserts to seat down on there, and the inserts still lock in as they normally would, but this eliminates having to have a larger bore diameter for the use with the standard flange style. So what we're going to do is we're going to go ahead, and I'm going to show how this is done with this particular kit for demonstration purposes, as it's a relatively uncommon kit to be used, because most of the repairs like this would be done for a hole kind of like this one here where you have a surface mount, or another one like this right here where you're going to have a surface mount and it's easy to get to. So right, let me get some stuff together and we'll get going. Okay, before we get started on this, I wanted to kind of give a closer up view of what the entire contents of this kit are. So you can see I have it laid out here. So you can see it does have the Sharpie included, the measuring stick, the drill bit, the actual drill stop, which is this piece right here. And what that's going to be used for is, once you measure, you're going to set your depth so you don't drill through the back side of the crankcase, because this is an oil chamber passage hole also, so you can't go out the back side of this hole and just go in from the back and have it be clearance. Then you got here, you have your tap, of course, and then your insertion tools. You can see these tools are longer than the average kits. Then up here you're going to have the actual tap guide, which they include in the kit, and then your actual inserts. Now, I don't know if you're going to be able to make this out on the camera, but you can see these inserts have a little bit different. They don't have the actual taper on them. They have more of a tiny little chamfer on the top side, which is what the difference is for these, because you have a tight tolerance counterbore there for the bolt to pass through. Okay, so here's what we've done so far. So we've got everything laid out, and I showed you guys that in the video. So the first step that you have to do here when you're getting ready to drill this hole and get ready to put the Time Sert in is you have to measure down into this counterbore to where your first damaged thread is. So in essence, where the threads originally were beginning at in the depth of that hole. And when I measured down, again, this is going to be different for every application, so you can't use my number as the one number you're going to use. But for this particular application, I had to get my bore scope out, my light, and do a couple different checks, because there's a couple different steps within that counterbore from the machining process that were you could have confused for being the proper starting point for the thread. So when I measured down like this, I came down to 72 millimeters, okay? And the reason this is sitting up right now, it's sitting at 74 millimeters. And what you're supposed to do is you're supposed to, according to the Time Sert instructions, take the measurement depth you take on this, add 2 millimeters to it, and that is going to be where you're going to set your drill stop. And the reason that is because you have the step on the actual drill here where you're going to have to allow for that 2 millimeters of that cutting portion. So I have set my drill stop to the 74 millimeters. So again, 72 millimeters to the beginning of my thread, plus the 2 millimeters per the instructions in Time Sert, for a total of 74 millimeters. Okay? And one way you can just confirm before you go ahead and drill this thing is this is a one-time deal. You drill it wrong and you're out of luck. You can kind of set it down in there like that and you can just gauge your drill stop based on that, and you're going to know that, okay, if I have about that 10-15 millimeters there, I'm going to get a good cut, and then thus the Time Sert will have a good portion to bite on. The other thing you want to do, you want to double check, also take it, set it down the back side for my application, make sure we're still nowhere near the bottom of this hole, which we're not. We're sitting at about 10 or 15 mils away from the bottom of the hole. So we know we have a good depth set on here. We know we're going to be biting into good material, and thus giving us a good surface to tap into. So we're going to go ahead and drill this hole. And again, you're going to want to go down to where the drill stop is, and that's where you're going to want to end it. You don't want to go any further than that. You don't want to force it. You don't want to do anything. So we're going to go ahead. We're going to start cutting. Right down to my drill stop. And back it out just like that. That's all you want to do. Okay? We're going to want to blow the hole out here. Make sure we get all the material out. Let me get a towel. And I'm going to clean out these crankcases so the shavings are not going to be in the motor. Don't worry about that. Okay, got the hole cleaned out. So next step we're going to have here after drilling the holes, we're going to have to tap the hole out that is going to put the threads in there that are going to accept the insert. So make sure you always are lubricating your tap. I mean, in this case, using some WD-40, you can use grease, cutting oil, something like that. You're going to want to make sure you use your tap guide because you're going to be on a surface that's not necessarily completely straight. So use your tap guide. And I'm just using an actual tap socket and my 1/4 inch drive. I don't want to use a bigger one, a bigger socket wrench, because I don't want to have to worry about breaking this tap off. So you go ahead and you cut this. We're going to go down. Looks like I'm going to be bumping into my tap guide here. In which case we'll go ahead and pull the tap guide out now that we've started the threads. And I'll continue cutting deeper. I don't have enough material cut yet to feel comfortable with for the insert to seat. So we'll go ahead and we'll go back in. We'll throw a little more WD-40 on it. And I'm going to start this by hand so I don't worry about catching the wrong thread. So we've caught the threads right there. We're going to go down to the point where we can not do it by hand anymore. And then we're going to go ahead and continue cutting here. And we're going to want to go down until you feel some resistance in the bottom. Bottom line is you want to cut this deep enough to the insert you're putting in. See right there we feel enough resistance, we're going to want to stop. Okay? So we've got a good thread down in there now to accept our insert. Go ahead and we'll pull this off, back it out by hand. And you can see we got good material removed. We're going to want to go ahead and look down inside the bore now. Look at our threads. And I can see a very, very good cut thread down inside of there now. Okay. Okay. Next step's going to be putting the insert in. Now, these inserts, you want to use some oil on the actual driver tool itself. That way you don't have any binding going on. You're going to want to take the insert, and you're going to thread it on by hand as far as you can go until you feel some resistance, which is about right there in this case. I like to use a little bit of Loctite in situations like this. That will just guarantee that after the insert is flared in the bottom of the hole, that it's not going to have an issue coming out. Okay? So what we're going to go ahead and do, let me go get my tap socket that fits this. Be right back. Okay, so I've got my tap socket. What we're going to go ahead and do is we're going to go ahead and start this thing down inside of their newly formed threads by hand. Until we feel some resistance. What we're going to do is we're going to go ahead and take our 1/4-inch socket wrench again with our adapter, and we're going to drive this insert in. And you want to keep going. You're going to feel some resistance on the actual insertion tool. And what that resistance is that flaring out of the actual insert itself. So you want to keep driving this thing down. There's your resistance you're going to start feeling. And that's the flaring of the actual insert. You want to just continue to carry past it. See, we've now gone past the resistance until you feel a kind of a hard stop. Now that insert is locked in place and it's not going to come out. Now you can remove the tool. And now you have a repaired thread hole. Okay, that is the M8 1.25 E-Core Time Sert insertion tool training exercise. Thanks for watching.